just like there are inverse to sine functions, there's also an inverse to a cosine and tangent function. So the first one we've already kind of talked about. So again, just kind of repeating it, y equals the arcsine of x if and only if sine of y equals x, with a domain between -1 and +1 and the range of -2 and, or sorry, negative pi over 2 and positive pi over 2. I'm going to add a third or another column here. We're going to call this the quadrants column. And for sines, we were talking about quadrants 1 and 4. For arc cosine, so again, similarly, y equals arc cosine or inverse cosine of x if and only if cosine of y equals x. So again, the domain is between -1 and +1. We never get a y or a cosine value greater than 1 or less than -1. But in this case, our range is going to be between 0 and pi. So we're really focusing on quadrants 1 and 2. For arctangent, same thing, inverse tangent, arctangent. Arctangent of x is only, or y equals the arctangent of x if and only if tangent of y equals x. The domain in this one, you can have an infinite domain, or you have an infinite number of answers. It can go as high as you need or as low as you need. That's not, need is kind of a relative term there. But anyways, the range is between -pi over 2 and +pi over 2. So again, we're focusing on quadrants 1 and 4, just like we did for the sines. So looking at our graphs here, similar in nature. The domain of the sine, again, we said was our x values. Those are real numbers, as long as they are between -1 and a +1. So -1 less than x, less than 1. The range goes from, well, those are the y values, and those are between -pi over 2 and +pi over 2. So -pi over 2 is less than or equal to y, is less than or equal to +pi over 2. For the domain of cosine, same deal. X is an element of the reals, and our x values are between -1 and +1. So -1 less than or equal to x, less than or equal to 1. And our range for cosine is still with the y values. So we got y is an element of the reals, and in this case, we're going to say it's between 0 and positive pi. So we have 0 less than or equal to y less than or equal to pi. Taking a look at that graph there, it goes as high as pi and as low as 0. The domain for our tangent, you can technically plug in any x value you want and it'll work. So no restrictions on that. Our range is going to be similar to what we saw for sine. So we're going to say y is an element of the reals. But the only restriction, you'll notice on this graph here, this graph is going to keep going closer and closer and closer to that line at pi over 2, but if you were to keep going, it's never going to quite get there. Similarly, on the left side, it's going to get closer and closer to -pi over 2, but never quite get there. So we're going to say -pi over 2 is less than y is less than, not less than or equal to, just less than pi over 2. So it's never going to quite touch -pi over 2 or +pi over 2. Sorry, waiting for AirServer to catch up. There we go. Now, the next step, we're asked to find the exact values of the following trig functions. So I'm actually going to shrink this screen again, and we're going to look at the unit circle and see if we can keep up with where we're going. So the arc cosine of pi over 2. So we're looking essentially where pi over 2 is equal to, where cosine is equal to root 2 over 2. Sorry, AirServer's taking a bit. So we're looking for where cosine is equal to root 2 over 2, and that's at pi over 4. So again, this is true because cosine of pi over 4 equals root 2 over 2. So again, it's kind of like logarithms. We're really looking for like the inverse. So similarly, inverse cosine of -1. So we're looking for where the y value, the x value, the cosine on the unit circle, is equal to -1. Well, let me zoom back out on this one. So the cosine is equal to -1 at pi. So again, inverse trig functions, we are looking for, sorry, AirServer is being really slow right now. But we're looking for, there we go, what angle measure makes this statement true. Arc tangent of 0, we're looking for where tangent is equal to 0. Now, on this unit circle, I don't have tangent listed anywhere. But tangent, remember, is tangent of some angle equals y over x. In other words, we're looking for where on the unit circle y over x would give us a value of 0. Well, looking at this, the only way to get 0 from a fraction would be having 0 as our numerator. So the sine 0 over 1 would work, so it'd be at 0. Again, that's because the tangent of 0 equals 0. Now that one's a little redundant because, oops, sorry, I'm not on that screen. Because the tangent of 0 equals 0, it's a little confusing which 0 is which, but we're going to figure this out. Tangent, inverse tangent, there should be a little negative there. Inverse tangent of -1. We're looking for where the tangent is equal to -1. So again, where does tangent equal -1? So on our unit circle, we got to figure out where y over x is going to be equal to -1. Well, the only places it could be is at 3 pi over 4 and, well, down here at 7 pi over 4. Going back to our restrictions for our domain, or for our range, our outputs can only be between -pi over 2 and +pi over 2. So that means we're working in quadrants 1 and 4. So in quadrant 4 is where we'd see it if we were to take the y value, the -√2 over 2, divided by the +√2 over 2. That would give us -1. But we're going to describe that as -pi over 4. Because again, we got to talk about negative angle measures. So if we were to start at 0, rotate downward to pi over 4 to get to that same coterminal angle, that's where the tangent would be equal to -1. So again, tangent of -pi over 4 would equal -1. Arc sine of 0. So where is sine equal to 0? Well, that's at an angle measure of 0 radians. Inverse sine of -√2 over 2. So on our unit circle, looking for where the y is equal to -√2 over 2 in quadrants 1 and 2. That's down here at 7 pi over 4. But we used that one earlier. We described that as not 7 pi over 4, but rotating that down -pi over 4. Last couple. Arctangent of √3. Oi. So, oops, sorry, I just realized. Oh, there we go. Arctangent of √3. Now, that one's not as easy to identify, but kind of paying attention to these ones that have a √3 in it. We probably should just go ahead and find the tangents of pi over 6 and pi over 3, and that's going to help us out. So, tangent of pi over 6. Tangent of pi over 6, we're going to take the y value, 1/2, divided by the x value of √3 over 2. So, putting that in more manageable terms, we're going to do 1/2 times 2 over √3. Reducing this, we can cancel out the 2's, so we're left with 1 over √3. But remember, we've got to rationalize the denominator, so we're going to multiply numerator and denominator by √3, which gives us √3 over 3. Okay, similarly, tangent of pi over 3 uses the same fractions, but reciprocal of that, so we got 1/2. So, I said it and I didn't write it. √3 over 2 divided by 1/2. So we end up with √3 over 2 times the reciprocal of 1/2, so times 2 over 1. So this one's a little nicer because the 2's cancel out. We're left with just √3 over 1, or just, in other words, √3. So putting that back into this, the arctan of √3 is what angle measure would give us the tangent equal to √3, and in this case, it would be the angle measure pi over 3. Again, that's because tangent of pi over 3 equals the square root of 3. For the inverse tangent of -pi over 3, well, we just found that the tangent of pi over 6 gives us positive √3 over 3. So if we were to kind of use some logic here, it would be the -pi over 6 that would give us the negative √3 over 3. Again, that's because the tangent of -pi over 6 equals negative √3 over 3. Last one, arc cosine of -1/2. Sorry, I'm not on the screen right now. There we go. Arc cosine of -1/2. So where is the cosine equal to -1/2? Again, going back up top, cosine is only in quadrants 1 and 2. So, zooming in on that, we're going to look in quadrants 1 and 2. Where is cosine equal to -1/2? That looks like it's over here at 2 pi over 3. So we got to really just rely heavily on the unit circle to help us find out where those angle measures are.